Okay, this screencast goes over rate homework 2 for AP Chemistry, and so we're just going to look at some of these introductory rate problems. As we go through this chapter, you might feel like there's 100 different rate equations. Hopefully we can clear some of that up so you know what to use where. But remember, the general form for rate is a change in concentration over a change in time. And because they don't give us any more information for this particular problem, that's the one that we're going to operate off of. So they tell me the initial concentration, and so we'll put square brackets around this and put a little 0 because that's our initial concentration at time equals 0 seconds. And they tell us the reaction rate, so that's our R. And they want to know what the concentration of peroxide will be after 35 seconds have passed. So what I did is I just used this equation right here, that rate equals the change in concentration of that peroxide over the change in time. And I knew the rate, I knew the change in time, and so I just solved for the change in concentration. So that's my change in concentration right here. And then that didn't quite answer the question because they want to know what my final concentration will be, or my concentration at T equals 35. So my change in concentration is the final minus initial. And so I plug in those values since I have both of those and solve for the concentration of peroxide at T equals 35 seconds. And I got 0.2220 molar. All right, so then in part B, they give us an initial concentration and say 12 seconds later, and they give us another concentration. And they want to know what the rate of this reaction is. So again, I've got to use this general rate equation, that rate equals the change in concentration over the change in time. They give me enough information so that I can calculate my change in concentration. So that's my concentration at T equals 12 seconds minus my initial concentration, and I get 0.0048 molar. So plugging it into this equation, I know that it changed 0.0048 molar in 12 seconds. And so that's 4.0 times 10 to the negative 4 molarity per second. I made it negative because the amount of peroxide is disappearing since it's our only reactant, and we would make those rates, that rate of disappearance, negative. Then I just used some dimensional analysis to change my molarity per second to molarity per minute. And I got negative 2.4 times 10 to the negative 2 molarity per minute. All right. So going along with this, I told you need to be really, really conscious of how rate is given to you and what's it in terms of. So with this kind of mock equation, they give us the rate in terms of the disappearance of B. So in question A, they are asking what is the rate of disappearance of A? So what I saw here from this balanced equation is that for every A that's used up, it has to use up 2 B's. So B disappears twice as fast as A appears from those coefficients. And so the rate of A is going to be the rate of B divided by 2. And I got negative 3.1 times 10 to the negative 4 molarity per second. Again, it is negative because it is a rate of disappearance. Then in B, they're asking for the rate of formation of D. So for this one, I decided that it was going to be more simplistic to compare D to A than to B, but I could have done that. I just saw this as a 1 to 3. So for every A that disappears, 3 Ds are going to appear. And that's what I said here. And so I said the rate of D is equal to 3 times the rate of A. Since this is a rate of formation, it would be positive at 9.3 times 10 to the negative 4 molarity per second. All right, so then in number 3, you're given a problem and some experimental data, and we're trying to figure out the order of the reaction. So we're trying to figure out from this base rate equation right here, what is X and what is Y. So we can do that by comparing two different experiments. I noticed here in the data that if I compare experiment 1 to experiment 2, the concentration of I is held constant, and that way I know it'll cancel out and make my math a whole lot simpler. I also noticed that comparing reaction 2 and reaction 3, that the amount of this S2O8 negative is going to be constant. And so that will cancel out. So that helped me pick out the reactions I need to compare so that I can solve for X and Y. So again, we start with that base equation, and we're just going to compare them, and we compare them by dividing them. So I took reaction 1 and divided it by reaction 2. These numbers all came from the data for experiment 1, and I just plugged it into this basic rate equation that I wrote here. When I compare reaction 1 to reaction 2, I find that X is equal to 1. So then I compare reaction 2 to reaction 3 to see if I can figure out what Y is. So again, the information comes from this data table, and I put it in the form of the rate law expression. And for that one, I find that Y is also 1. So the answer to this one is that it is first order with respect to S2O8 negative. It is first order with respect to I negative, and it is second order overall. To get the overall order of a reaction, you just have to add the coefficients together. So 1 plus 1 is 2. Then they ask me for the value of the rate constant. So now I know my rate law and I know what X and Y are. So I'm eliminating some of those variables that are in there. Using the data from experiment 1, I just plugged information in here. And since X and Y are no longer variables, I don't have to solve for those. And I can just solve for K. So in taking this, and you really have to work with your units, a lot of times on the AP exam, they do specifically ask for units of K. So for this one, what I ended up doing is I took this 1.5 or 1.4 times 10 to the negative 5 and divided it by the concentrations of the S2O8 and the I negative in experiment 1. That left me with 6.1 times 10 to the negative 3, 1 over molarity second, is what K must have to be. Then in part C, now that we know K, we can plug everything in here and figure out a new reaction rate. So I used my answer here for K, and then I plugged in the values that they gave me in the problem into my rate law expression, and I could then solve for the rate. So in the next problem, it's a very similar type problem, problem number 4. We are going to be looking for the order of this reaction, and they give us some data. I noticed that in trial 1 and trial 2, the concentration of Cl2 is constant, and in trial 1 and trial 3, the concentration of NO would be held constant. And that's going to help me find my X and my Y in this basic rate law expression. First thing that I did here is compared reaction 1 to reaction 2. So again, I'm just using this basic rate law equation and plugging in the values from trial 1, and then using that same base equation, plugging in the values for reaction 2. This leads me to find that X is equal to 2. Then I compare reaction 1 to reaction 3 in the same way, and I find that Y is equal to 1. So here is my rate law expression, and I found the orders here. It is second order with respect to NO, and it is first order with respect to Cl2. And then that makes it third order overall. We just add 2 plus 1, and that gives us the order for the overall reaction. Then it asks us to find the rate constant K, including its units. I use my rate law expression and the data from trial 1. I just chose it because it's the first one on the list. And I can plug in this information, and I know the orders. So I just put the numbers in there, and I can solve for K. This time the units are 1 over molarity squared seconds. Then I write the rate law expression, plugging in all the variables. So R equals my K, which I plugged in here, and it's NO to the second power and Cl2 to the first power. All right, then I ask you to consider this graph here in number 5. and ask you which chemical equation would be consistent with this data. I came up with D. Initially, there is no A, so A must be a product. So it starts here and builds as time goes on. So that means B must be my reactant. So that eliminated A and C. And since A increases at a faster rate than B decreases, B yields 2A is the best answer choice. You can see on how much this decreases to how much this increases.